Hi, class. I realized in retrospect that I haven't covered this idea of relative versus absolute velocity very well. And so I'm going to kind of reteach it and then apply it to the example of me rolling through the hallway throwing the ball and see if that can help. Okay, so let's start by defining again our equation that we wrote in class. We wrote that the relative velocity is equal to the jet velocity minus the velocity of the control volume. And so this is kind of where I went wrong first, was using the notation v jet. Because this won't always apply universally to every jet. Instead, the idea is more of how you measure each velocity. So let's define each one in turn. So VR, this is the relative velocity. And this is measured with respect to the control volume. I'm going to define them in words, then we'll use an example to define them kind of that way. Okay, so relative velocity is the velocity measured with respect to the control volume. Okay, now I'm going to redefine this term not as V jet, but as V absolute, VA, where this is the absolute velocity. Okay, and this is the velocity measured with respect to a non-moving reference. Again, we'll explain what that is by analogy. Finally, VC, this is the velocity of the control volume, right? And this, we should note, is measured with respect to a non-moving reference. Okay, so we have the relative velocity is equal to an absolute velocity minus the velocity of the thing that you were measuring the relative velocity according to. Okay, so let's do an analogy to help explain this better. I'm going to write this equation up here. So relative velocity equals absolute velocity minus velocity of our control volume. So we're going to do a few different examples. We'll start with, we're going to do me sitting in the chair like we did in class, being rolled down the hallway. So we'll start with me sitting in the chair and I throw the ball. Okay, so we'll do this in red. So the velocity of the chair, aka the control volume, so the control volume is me in the chair, and the velocity of the control volume is equal to 0, right? The chair and the control volume are not moving. Now I threw a ball, right? And that ball, according to, let's say we have a person standing here and they have like a police speed gun, right? That can measure velocity. So that person is going to measure the absolute velocity of the ball. Let's say I threw the ball at 10 meters per second, okay? Now, let's say I have a speed gun as well in my other hand. And I measure the velocity of the ball, and I am measuring the relative velocity. And I also see it moving at 10 meters per second, right? Because I am measuring the velocity of the ball from the chair. So that was pretty easy because in this case, the relative velocity equals absolute minus control volume. Well, since control volume was 0, the relative velocity is equal to the absolute velocity, which is true. 10 equals 10. Okay, now let's do a different case. Relative velocity equals absolute velocity minus velocity of control volume. Now, we'll do the next case we did in class, where I'm on the chair and again, I'm throwing the ball, but now I'm flying through the air because someone has pushed the chair. Okay, so here's our control volume. I don't have any eyes. I have a red eye. Ooh, creepy. Okay, let me keep the colors the same. Yeah, so now the chair, aka the control volume, is moving. We will say at 5 meters per second. So I am moving in the chair. Now, let's do relative velocity next. So I threw the ball, right? And I threw it exactly the same as I did the last time. So I still threw it with the same force, just as I did before. So this means that, kind of like if I were standing still, I still threw the ball as fast as I can throw it. And how fast did I throw the ball last time? Well, I threw it 10 meters per second. And so I'm still going to see the ball moving at 10 meters per second, right? Because I had the ball and I threw it. And because I can throw the ball 10 meters per second, that is how fast I threw it. But, we did this in black. Now the person standing here measuring my speed with their speed gun is going to see something different. Why? Because I threw the ball the same speed I always throw it. I can throw it 10 meters per second. But I am moving as I throw it. So they're going to see an absolute velocity of 15 meters per second. The velocity I threw the ball plus how fast I was moving as I threw it. And this checks out, right? Relative velocity equals absolute velocity minus velocity of the control volume. So I thought I measured it as going 10 meters per second. That's how fast I threw the ball according to my speed gun. But then this person measured it going 15 meters per second. And that makes sense because I was moving 5 meters per second. And this is all in the I hat direction. I have not been using vectors, my apologies. I didn't plug anything in here. So this is all purely in the x direction. And so the relative velocity, AKA the speed at which the ball crossed the control volume, sorry, the control surface, is 10 meters per second, because that's, when I was holding still, that's how fast I could throw the ball. And so I haven't changed. The only thing that's changed about me is I'm moving, but my body can still throw the ball at 10 meters per second. So according to me, that's how fast I threw it. But because I'm moving, the ball itself is moving 15 meters per second, according to this guy. All right, let's do it again, but do the example I showed. Do our third example in class, which was I was on the chair, but now the chair was pointed the opposite direction. So now my hair is flying this way. And I'm still throwing the ball, but I threw the ball this way. Oops. Okay, so I am going to draw control volume around myself. So now my control volume is still moving at 5 meters per second this direction, in the x direction, right? But I threw the ball, I use green for this. So my other hand actually has my speed gun, and my speed gun detects that the ball is moving to the left at 10 meters per second, right? Because that's how fast I can throw the ball. Every time I'm throwing the ball at 10 meters per second, because that's how fast I can throw the ball, right? There's a negative this time because it's moving to the left. All right, so now I am moving to the right. The ball I threw to the left. So what is the person with the speed gun on the ground going to see? Right, well, let's figure that out. VR equals VA minus VC. Well, the relative velocity, again, is the speed with which the ball crosses the boundary. Right? So the relative velocity is the velocity measured with respect to the control volume. When you figure that means the speed at which the ball is crossing the control surface. So the ball crosses the control surface at 10 meters per second to the left. So I'm going to write a negative 10 meters per second I hat. That's going to be equal to this velocity vector, which is what I'm trying to find. This is, of course, what this person is going to measure. And this then we subtract from the velocity of the control volume, which is moving to the right at a speed of 5 meters per second. This negative came down from the equation. So this is a positive 5 meters per second, but it is subtracted from the absolute velocity. So now we can move this to the other side and find that the absolute velocity of the ball is negative 10 meters per second I hat plus 5 meters per second I hat, which is 5 meters per second I hat. So according to this guy, the ball is actually moving to the right. Oh, whoops. Sign error, -1. Okay, so there's a negative. Negative 10 plus 5 is negative 5. So according to this person, the ball is actually moving to the left, but only at negative 5 meters per second. Okay, I hope this helps clear up what relative velocity, absolute velocity, and control volume velocity are. So now let's apply it to our boat problem. So we have a boat. And we're saying that according to the boat, there is a jet of air leaving the nozzle. So the air leaving the nozzle is traveling at 300 meters per second, right? So this is already measured with respect to the control volume. The keyword is the air leaves the nozzle at 300 meters per second. So the air is exiting the nozzle, and according to the nozzle, it is going 300 meters per second. Well, guess what? The nozzle, we can draw this like this. Let's draw our control volume to end at the nozzle. So that is the speed at which the air is crossing the control volume. So the relative velocity is negative 300 meters per second I hat. In other words, the speed of the air crossing the control volume. Sorry, the control surface being the section of the control volume that the air is passing through. So this is already the relative velocity, right? We do know that the boat is moving to the right at 10 meters per second. So if we wanted to, we could actually solve for the absolute velocity of the air. We do not have to do this, but if someone is on the shore with their radar gun, and if they are measuring the speed of the air exiting the boat, well, we know that according to the boat, the air is exiting at negative 300 meters per second I hat. They will be measuring the absolute velocity, so we will leave that as unknown. And we know that the control volume is moving to the right at 10 meters per second I hat. Right, and so we can find that the absolute velocity is equal to negative 300 meters per second I hat plus 10 meters per second I hat is equal to negative 290 meters per second I hat. So according to according to this speed gun, the air is moving to the left at 290 meters per second, but that is not what we care about. Remember, the sum of the forces on our control volume for a moving control volume is equal to the sum over all outlets of the mass flow rate times the relative velocity minus the sum over all inlets of the mass flow rate times the relative velocity, where the mass flow rate is defined as the density times the area times the magnitude of the relative velocity. So you see, everything is the relative velocity. And this is because what is the actual rate at which air is leaving our control volume? Well, that depends on how fast the air is crossing the actual control volume. How fast is it actually leaving the control volume? That depends on the relative velocity, right? So I think this has hammered this concept home enough that the relative velocity is the speed at which our fluid is crossing the boundary. And you see, since our velocity was already measured with respect to the boat, it said 300 meters per second from the nozzle, then we know that this is already the relative velocity, and that the absolute velocity will be different, but we do not need it, because while doing our force balance, we must use a relative velocity. Okay, I hope this clears things up. Please let me know if you have more questions.